Hi everybody, so we're going to talk about some other derivative rules, namely trig and exponential rules. So the trig rules are really quite simple. And in fact, if you look at sine, think about this one. Here we'd have a slope of 0. Here we'd have a slope of 0. Here we'd have a slope of 0. The derivative of sine happens to just be cosine, right? They're the same thing. Derivative of sine is cosine. So you're like, aha, the derivative of cosine must be sine, and annoyingly it's not. But that's confusing when it becomes red against cheese. Let's make it purple or something. Black, whatever, it doesn't matter. It's almost negative sine, but if you turn sine back on, notice the derivative of cosine, which is in black, and this one, which is in red, sine, are almost the same, except they're kind of reflected over the x-axis, which really means that the derivative of cosine, again, here's cosine, original graph, black derivative graph, that is negative sine of x. And you can check that. It's actually in your formula booklet. Not too terribly bad. And then the last one, which we have not yet talked about, is the derivative of tangent. But I want to remind you about something real helpful here, is that, what letters have I not used yet? W of x is tangent of x. And the derivative of that is very strange. But tangent of x is actually the same thing as sine over cosine, right? So if I just graphed sine of x over cosine of x, notice that that kind of maps right onto my tangent of x graph. And so if you use the quotient rule, you can figure out very, very slickly that the derivative is -1 over the cosine squared of x. Oops, not negative, just 1. Silly Perkins. Not enough coffee this morning. That's what's going on. It's fine. Okay, but again, all of those are in your formula booklet, so you don't have to memorize them. Just get familiar with using them, okay? And then exponential rules, this one is kind of fun. So here is 2 to the x, and the derivative of that. I'm going to actually make this also black, and I'm just going to make it dotted, so the derivatives are going to be dotted. Okay, so you'll notice 2 to the x is kind of above the derivative here, and then we're going to have 3 to the x. You can leave that on there. And let's get the derivative of 3 to the x. And we'll make that blue. Come on, you can do it. And we're going to make it dotted. And here I want you to notice, so like 2 to the x is solid, right? And it's the black. And its derivative kind of hangs out below it over here. 3 to the x is solid, and its derivative kind of hangs out above it here. So it's actually somewhere between 2 and 3 that you get a function that has a derivative that is the same thing as itself. And we actually talked about this really briefly, but just as a reminder. So here is we're going to make this orange. And I'm going to zoom back out. Great. As I make b a bigger number, right now, so b is 1.6. Let's get the derivative of that, so p prime of x. And we're going to make that orange, but it's going to be a dotted line. So the derivative of the orange line hanging out there, and we're just looking for exponent, so base to the x. Notice as I continue on, that dotted line gets closer and closer to the orange line until eventually the dotted line crosses over the orange line and kind of takes over. And you're like, well, when does that happen? So it's like dotted line below, dotted line above, dotted line below, dotted line above. Somewhere in there, they have to be the same thing. And because I already told you what the answer is here, I'm going to make this 2.7, and I'm going to make this 2.8, and I'm going to make the step really stinking small. We're going to turn these off so you can actually see it. We're going to zoom the snot in. And it really gets to be really, really, really like, oh, they're the same. And then they're not the same, and 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 they're really, really, really close to the same, round about 2.7. And so what you're going to do with these, it's really awesome, is it's really e to the x, where you get the derivative is the same as itself. So the derivative of e to the x is e to the x, which is pretty stinking sweet. And what you're going to have to do is remember, very, very strangely, that, 2 is the same as 2 to the power of the natural log of 2. Nope, just kidding. What do I want to do? E to the power of natural log of 2. Oy vey. We're going to be doing a lot of that stuff. That we'll dig into way more next week. Don't freak out. Don't panic. For right now, if you believe me that e to the x, which we're going to name a function z of x, that it is the derivative of itself. That's what I need you to know. So turning this off. The derivative of e to the x is e to the x. E to the x gives you e to the x, gives you e to the x, gives you e to the x, and then if we want like the derivative of 5 to the x, we're just going to rewrite 5 as e to the natural log of 5. Don't panic about that. Okay, trig rules, exponential rules, they're all in your formula booklet. How do I stop this thing? God, this is so awkward.